that we need to know. The nth root of a number a can be written as the radical expression, the square root of n to the a, where n is the index. This is the radical, and whatever is inside the radical is the radicand. And if you don't see a number outside of the square root, or if you don't see an index number, you can assume that it's 2. So for this, we're just dealing with a positive root, but there are negatives really also. But we're just going to talk about the positives. And there are 2 ways to really go about doing this. There's a couple, and I'm going to show you the different ways, and you choose whichever way feels most comfortable to you. But first, one of the ways requires us to know the perfect squares, so that's 1 squared, 2 squared, and keep going. Let's list out the first 12. What would 1 squared be? 1. 2 squared?
4.
3 squared?
9.
5.
15.
I skipped 4, yep. And then 5. 6. 7.
49.
8.
64.
100. Skip 10, but
Okay, 100.
and then 121 and 412.
48.
44. So keeping these in mind will help us simplify this faster, but there are other ways to go about doing this. So if we have perfect square roots, you just simplify those like normal. So the square root of 16 would be 4. Here we have the square root, 2 times the square root of 121. The square root of 121 is 11, and it would be 2 times 11. These ones aren't up here. It might be helpful to know up to 15 or 20 perfect squares, but you could always use your calculator to get those. Find the square root of 289. And then multiply 6 and 17. Say that number one more time. 1. And then I'll leave 4, and you could go and find that. But a lot of the ones that we do won't have perfect squares that we can just simplify, because if you put the square root of 32 in your calculator, what happens? Yeah, you get decimals. We don't want that. We want to leave it in simplest radical form. So this is one way, and then I'm going to show you the other. So we'll do it with perfect squares first, and then I'll show you the other way you could possibly do this. So think about the factors of 32, but think about which of those factors are perfect squares. 4 and 8. Okay, that's going to be the one I come back to. When you do this, you want the highest perfect square that can go into it. 2 and 16. Right? And then if you weren't thinking perfect squares, that'll be the other way we do this. But 16 is the highest. So if I were to break this down to the square root of 2 times the square root of 16, this, if I multiply them together, if you know your sound is on, please don't turn it off. If I multiply these together, I would get the square root of 32. And I know the square root of 16 is 4. So what happens is this stays outside of the radical, and this stays inside the radical. So if I put in the calculator 4 times the square root of 2, I should get the same decimal as the square root of 32. Questions on that method? So you can do that for all of these. Or, let's say you're not thinking perfect squares, but you just think of two factors, 4 and 8. You start off the same way. You know 4, the square root of 4 is 2. However, 8 can be broken down more. So whatever numbers you pick, you may be breaking it down a lot. What are factors of 8? Either perfect squares or... so if I did 1 and 8, that wouldn't change anything, but 2 and 4 would. So again, we know the square root of 4 is 2. So I'm going to multiply those two together and leave this inside the square root. You get the same thing, it's just a longer process. Whichever one you feel more comfortable with, you could do that. That was it. I was thinking there's another one. Okay. Questions on that? We won't do all of these, but we'll do a good majority. So let's try 180. We'll do this both methods, and then I'll let you guys choose. For perfect squares, think of the highest perfect square we can divide 180 by. And you may have to check. Sit up one more time.
5 times 36 is 9.
Okay. So 5 and 36. And we know the square root of 36 is 6. So our final answer would be 6 times the square root of 5. And just so you see that that works. You get the exact results. So that's how you would check yourself in Desmos also. Let's say I said I know 10 times 18 would give me that. But now I have to break both parts down. So give me factors of 10 and factors of 18.
6 and 3.
Okay. Can I break any of these down again?
6.
6, 2, 2, and 3. So then I have, what's my final answer? 6. Okay. I have a pair of 2s and a pair of 3s, all technically underneath the radical. Any pairs you see get to come out, outside of the radical. That would be outside. So, and that would just be one group of 2s, one group of 3s, and then whatever's left stays inside the radical. So you would get the same thing. Let's try number 10. Which method do we want to use? The perfect squares or the breaking it down? Perfect squares, okay. Find a perfect square that goes into 54. Which one? 6 and 9. And the square root of 9 we know is 3. So we're going to bring that outside, multiply it to the 2, so that our final answer is 6 times the square root of 6.
So when that happens, it means that there's a higher number that you can
This,
square down. Because it happened on the one.
no. This 2 was already on the outside, so we have to multiply it. But if you, oh wait, because we didn't break down. This is the perfect square, so that would have been 3 times 3. But if I broke this down, that would be 2 times 3. And there's nothing else to simplify. So that would come out, but those would still stay in. Okay. Any others on this page we want to see, do, go over before we talk about some more on the next page? knowing your perfect squares if you're doing perfect square method is key to being able to simplify this correctly. Okay, look at 11 through 14. Which of those do we want to see can we go over and have questions for? Perfect squares or breaking it down? Okay. And if you want to do breaking it down instead, feel free to do that. So think of a perfect square that you could divide 150 by.
150 divided by 6 equals
25, okay. So we have negative 5 times the square root of 6 and 25 is 57. The square root of 25 is just 5. What would that final answer be? So simplify it. Negative 25 times the square root of 6. Someone check that in your calculator. Double check that the decimals match. Any others in that section before we move on to perfect cubes? Okay. So these you may not know off the top of your head, but you're doing 1 cube, 2 cubed, and so on and so forth. So 1 cubed would be 1. And you can use the little caret, or you can use the square and change it. 2 cubed. 8. Remember, it's whatever it is times itself 3 times. 3 cubed.
Oh, I thought we were doing squares.
3 times 3 times 3, yes, 27. 4 cubed. 4. 5 cubed. 125. It's 5 times 5 times 5. 6 cubed. 7. 8. 9. And 10. So here you have to change your mindset because you want to do perfect squares because that's what you're used to, but you really have to think about your perfect cubes. And know that we're dealing with cube groups, so groups of 3, not pairs. So again, if I have like this one, the cube root of 347 is 7. So that would be 5 times 7. Our square roots cannot give us negatives. We can't have a negative underneath the square root, but the cube root can. So if you see this, it's not no solution, but if you saw the square root of negative 27, that would be. For 18, this would become, you could bring the negative out to make that negative 2. And then the cube root of 1,000? 10. So that would be negative 2 times 10. The methods are the same. So when doing this, you could look for which factor is a perfect cube that would go into 40. So let's try that. Which of these should we divide 40 by? Which of these? 8. So So I would do the cube root of 8 and the cube root of 5. And I know the cube root of 8 is 2. And I would just leave it as the cube root of 5. If you want to put parentheses around that, so that you know it's not 2 cubed times the square root of 5, but 2 times the cube root of 5, you could do that.
What would you do with the 5?
8 times minus 40. Now, if we were breaking this down, let's say we use 20 and 2. Not perfect cubes. I'm just going to write these as this without the cube roots right now. I want to break down 20 completely. Give me factors of 20. Under 10 and 2. And then 5 and 4 would have also worked. And then for 10, we have to break that down again. 5 and 2. And we're looking for groups of 3 that would get to come out. So just the pair of 2 wouldn't work. That group of 2 would come out, the 5 would stay on the inside. And that's how your grouping would work, or if you're breaking it down like that. Questions on that before we try some others? Let's try 20. We'll do both again. Find the perfect cube that we could divide this by. What did you say? 64 and you said 27? I don't know which is the right answer. So I'm going to say 64 works. This one would give us a decimal, so that one wouldn't work. 64 and 3. So then if I simplified this down, what would my final answer be?
Eight.
64 times 3 gives us 192. Not 8, not the square root of 64, but the cube root of 64. So 4. That's where you have to switch your mindset. Because you'll see that and want to do 8, but that's wrong. Questions there? Okay, if we broke that down, you could always break it down if it's even by 2s, but then you just end up with a lot of 2s. Besides 3, give me something else that goes into 192. We'll start dividing by 4, not 5, by 6. What's something else that goes into 192? 12 and 6. 12 and 16. Okay. So again, I'm just going to write the numbers so we can break them down. So give me 2 factors of 12.
3 and 4.
4. 2 factors of 16. Okay. And then you could stop there because we have a group of 3, or you could break down each group, each 4, and you'd have a bunch of 2s that would get broken. That would come out also. So either way, that would work. If you broke down all the 4s, you'd have 3 sets of 2s, and that would be 2 groups of 2s. So 2 times 2 is 4. Let's do 22. Perfect cubes or breaking it down? Okay. And if you want to do breaking it down, that's fine. Find a perfect cube that would go, actually first, let's take out the negative. And then find a perfect cube that would go into 250. 125 and multiply these on the outside, leave this on the inside, simplify this, and multiply that out. What would that final answer be? There's a lot going on. The order doesn't really matter. You will eventually need to multiply those together. Simplify this and multiply that to those.
But multiply the -2 with
Yes. What would that final answer be? So that'd be this part, but then you have to multiply to this. 10 times the cube root of 2. This would be 5, this would be 2, 2 times 5 is 10, leaving the cube root. Which part are you confused about? This part?
Yeah.
2 times 5 is 10. Just like your square roots, you can check this in the calculator. So I'm going to put in the original and put in the last. In your calculator, if you go into math, number 4, that's your cube root. And then, what do we say, 10 times the cube root of 2? We did that right. Good job. Any others on this page you want to see through go over how questions? Perfect cubes or breaking this down? Okay. So find a perfect cube that goes into this. Seven and 7. Simplify the cube root of 27, multiply it to the -3. What's our final answer?
3.
This would be 3. So multiply -9 times the cube root of 7. Do you have any questions on how we simplify cube or square root so far? We're going to leave the variables part for Monday. So for the next 15-20-ish minutes, you could be working on TestNav. It should be working on iPads. JLabs, done some math. Previous, the ones that are due today. This one's due next week on Friday. So you have plenty of things to be working on. Work on something. Let me know if you want